Okay, example 2, find the inverse of f of x equals 2x plus 1 over x. X does not equal 0 and state any restrictions on this domain. So what they've done for us here with this x does not equal 0, they've already established the domain of this function. We can see x is in the denominator, divided by 0 is a bad thing. That's the only thing going on here. We can multiply x, or 2 times anything, add 1 to anything. Division by 0 is illegal. So our original function, again, f of x is our original function. 2x plus 1 over x is its structure. The domain of this function is the set of all x values such that x does not equal 0. Okay. As far as range on a rational function is concerned, we've graphed quite a few rational functions here in the last chapter, 3.5. Imagine some of the graphs we saw. Like we saw ones that went like this, and they had some horizontal asymptote, right? That horizontal asymptote would represent the value of y that's not possible to happen, right? We also had some that maybe it had a slant asymptote. We'll pretend that's dashed. There we go. Slant asymptote, and like so maybe, and then maybe it does something like this, and there's a big gap there where y doesn't exist, right? So there's no y value. So the range would be everything above this and below that. So we'd have to find this maximum or minimum value. We're not going to deal with the uglier ones. We're going to deal with the prettier ones like this that maybe have a horizontal asymptote happening. Alright, so if you take a look at this, the highest power term on top is 2x to the first, the highest power term on the bottom is x to the first. You can see if we divide those two objects, 2x over x, it equals 1, right? So y equals 1 is the horizontal asymptote, and that's going to be my domain, that y is not allowed to equal 1 because that's what's going to happen here. So the range is a set of all y such that y does not equal 1. Or actually f of x. It's really technical here, f of x. And again, just put this in the box because it's going to be important in a few minutes. But for right now, that's what we need to figure out there. So we have a range of f of x is not allowed to equal 1. A domain of x is not allowed to equal 0. Now, if I go ahead and make the inverse function here, I start off with writing the function in yx form. So y equals 2x plus 1 over x. And again, to make the inverse function, I just swap all the x's and the y's. So every y becomes x, every x becomes y. Like so. And again, that's how you make an inverse function every single time. Every x becomes y, every y becomes x. You've made the inverse function. Then what's left to do is to solve that function. In this case, I'm going to cross multiply here, so x times y is one side, and 2y plus 1 times 1 is the other side. To get that to say y equals, I'm going to get all the y's to one side. I'm going to move the 2y over to the left, so xy minus 2y is equal to 1, which gets me to y parentheses x minus 2 is equal to 1. You know what? You guys should have corrected me.
I was gonna say I was looking at it the whole time. And
Yeah, that should be 2. I don't know where I got 1 from there.
I just didn't want to say something you'd be like.
Yeah, well, if I'm wrong, correct me.
Yeah, that's what I was thinking
Alright.
too.
I even got enough sleep last night. I don't know what's going on. Anyway, thankfully I noticed in my work, but yeah, 2x over 2 equals 2, not 1. So y equals 2 is the horizontal asymptote. So f of x cannot equal 2. Is that? So y parentheses x minus 2, common factor of y is taken out, x minus 2 is left over. Divide both sides by x minus 2 to get y equals 1 over x minus 2 is the inverse function. So again, writing good inverse notation, this y is our inverse y, so we're going to write f inverse of x equals the answer. And the domain of this is the set of all x such that x does not equal 2. Now again, if you take a look at the range here, this is the range. Right? Notice that I changed f of x into x because f of x is like y, right?
Yeah.
An inverse function, x's and y's swap places. Alright, so this x is not allowed to equal 2. Obviously in the function we got 1 over x minus 2, x is not allowed to equal 2. That verifies the fact. Okay, so that's kind of what you want to do here. I'm going to go out on a limb here and say that there's not going to be any breached horizontal asymptotes, so we're not going to have a graph that towards 0 is going to go under and back over to allow that to happen. In my recollection, they're all going to be, whatever the horizontal asymptote is, that's going to be a leveling out value. It's not going to be something that you can cross at any point. So those are a little bit more complicated, and for these inverse functions, we stick to the more basic level ones like this. So, again, if you can establish domain and range of the original function, the range of the original function is giving you the restriction on the domain in the inverse function.